Okay, this lesson is all about percent of change and percent error. So the first part says a percent of change is a ratio that compares the change in quantity to the original amount. It says we can use the percent equation to solve, and you can also use the percent proportion, just so you know, but we have to think of the part and the whole in terms of what we are comparing in the ratio. So today we're going to use the part is the change and the whole is the original. Typically when we look at part equals percent times whole, that's what it is, part equals percent times whole. Today it's going to be like our change equals our percent of change times the original. So we're still using that equation, it's just we're thinking of the part today as how it's changed. We're thinking of the percent as our percent of change and the whole as the original amount. If the new amount is greater than the original, meaning it went up, it's a percent increase. If it's less than the original, then it's a percent decrease. So for example, it says find the percent of change in the cost of gasoline from 1970 to 2010. Round to the nearest whole percent if necessary. So this is the original because it happened first. Okay, this is the new amount because it happened second. Okay, if you ever have a hard time deciding, it's original is what happened first. So first of all, we have to find our amount of change. To find how much it changed by, what you're going to want to do is take the two amounts and subtract them. $2.95 minus $1.30 is $1.65. That's how much it changed by. It went up by $1.65. Now, when you go to set it up, remember our change goes in as our part. We don't know the percent today. And this is the original. It started as $1.30. And we go to solve. Remember to do that. To solve this equation, you would divide by the number on the same side as the variable. That's really called the coefficient. It's just we wrote it behind this time because of the specific way we write out this equation. And when you do that, 1.65 divided by 1.3, I would get, typed it in wrong. I would get x is equal to 1.26923. And you don't have to write out all of those decimals, but you do have to write out enough so that when you move it back 2 times, you can tell what the percent is. Now, since it said round to the nearest whole percent, we're going to say that it's 127%, because the 9 behind it rounded up the 6. And this is a percent increase. From the original to the new, it went up. Okay, the new amount was higher than the original, so that's a percent increase. On example 2, it says Yusuf bought a DVD recorder for $280. Now it's on sale for $220. Find the percent of change in the price. Round to the nearest whole percent. So finding the change, I'm going to subtract the 2, which is a change of 60. Remember, our change is always our part. And then we put x times, and this is where people struggle, make sure it's the original amount. It started here as $280. then it went down to 220 because that's the new amount. It's on sale now. So the original was the 280. We would divide both sides by that 280 to solve. And I get 0.214. When I move it back 2 spots, that would be 21%. Since the price went down, this is a decrease. And I'm fine with you abbreviating, or if you write the whole word out, that's great too. Alright, the got it problem says find the percent of change from 10 yards to 13 yards. So if you need to, pause the video and try this if you're just learning it, okay? And that way you can see if you know how to do this or not. So on this one, what you would want to do is 13 minus 10 is 3, so 3 is our change, and we're trying to find our percent. The original is what it started with. It started as 10. To solve, I divide by 10 on both sides, and that gives me x is equal to 0.3. Since I'm looking for a percent, I have to change it into a percent, and that would be 30%, and that was going to be an increase. It went up from 10 to 13. Part B says the price of a radio was $20. It is on sale for $15. What is the percent of change in the price of the radio? So again, find our change. It was 20, now it's 15. So the change was $5. We're looking for our percent. The original was $20. That's what it started as, and now it's on sale. We solve. And when you do that, you get 0.25 or 25 hundredths. Change that into a percent. And notice it went down because it's on sale, so that is a decrease, 25% decrease. Okay, the other thing we might talk about is percent error. And that's very similar to percent of change, but this time the ratio is going to compare the inaccuracy of an estimate or the amount of error to the actual amount. So for our part, okay, our part is going to be our amount of error, and the whole is going to be the actual. That means this time around, when you think part equals percent times whole, you're going to be thinking the amount of error equals the percent error times the actual. Oop, and I wrote whole again. Okay, that's how you're going to think about it for this one. Very similar to the last one, because on the last one we started off by finding the part, which we had to subtract. Same thing on this one. It says Ahmed wants to practice free throws. He estimates the distance from the free throw line to the hoop and marks it with chalk. Ahmed's estimate was 13.5 feet. The actual distance should be 15 feet. Find the percent error. So on this one, we're taking the guess and the actual, and we're subtracting them. When you take the guess and the actual and subtract, that is their amount of error. That's how much they were wrong by. Okay? That's going to be written as our part. Then we have our percent, and this is where you have to make sure you put in the correct amount. We want the actual amount, not his guess. We want the actual, which is 15. From here you can solve. What you do to one side, you do to the other. So 1.5 divided by 15 we get x is 0.1. That would be 10%, and this time it's not an increase, it's not a decrease, that's how wrong they were, so this is the percent error, 10% error. Now in class we did an example that there was a gumball guess. You guys have all done things like this before, where you see a container with items in it and you have to guess the amount of items. Okay, when you are doing that, that's an example, a real life example of finding percent error, because you could put in your guess, you could say there's actually this many, then you could find what was your amount of error, how wrong were you. Okay, and we can do an example of this. So let's say your guess for this was that there were, I don't know, 36 gumballs. And maybe there's actually 28. So your amount of error would be 36 minus 28. You were off by 8 gumballs. So this is going to look like 8 equals x times, you use the actual. You're not basing it off of your guess, you're basing it off of the actual. And you solve. Divide by 28 on both sides. And I would find here 8 divided by 28 is 0.28571. If I asked you to round to the nearest tenth, it would be 28.6% error. I'm going to round it up because of the 7 behind it. So I would have an error of 28.6%. The Got It problem says, find the percent error if the estimate is $230 and the actual is $245. Round to the nearest whole percent. So we're taking our guess and our actual and subtracting them in order to find our amount of error. So they were off by $15. We're looking for our percent error when the actual is 245. We divide both sides by 245, and x would be equal to 0.06122, and it goes on. So when I round back, when I go back, the nearest whole percent would be a 6% error. Okay? If you have any questions on this, let me know and I'll be glad to help.